4.8, isosceles and equilateral triangles. So we're going to use theorems about isosceles and equilateral triangles. So if we recall that isosceles triangles have at least two congruent sides. When they have exactly two congruent sides, it looks like this picture here. The legs are the two congruent sides. So they would be AB and AC. The base is that third side. So it would be segment BC. The base angles are the two angles adjacent to the base. So that would be angles B and C. And the vertex is the angle formed by the legs. In this case, angle A. If two sides of a triangle are congruent, then the angles opposite them are congruent. So if I have AB and AC congruent, then angle B is congruent to angle C. And likewise the converse, if the two angles of a triangle are congruent, then the sides opposite them are congruent. So AB would be congruent to AC. So we're going to look at this diagram and see if we can find the congruent things based on the angles and the sides. So looking at AECE are congruent. So that means the angles opposite, so that would be ECA and EAC. If DAE, that's this little one here, is congruent to DEA, then the sides opposite would be DA and DE. If angle BDF, where's BDF? Here, congruent to DBF, is congruent to BFD. Now I know we didn't talk about equilaterals, and we will in that next theorem. It's still going to be the same thing. The sides opposite those congruent angles are going to be congruent. So we're going to have DB, DF, and BF. Likewise, if I have the three congruent sides, then the angles are going to be congruent. So what do we have? AB, this is the large triangle, BC, AC. So the angles, the large angles, so we have angle BAC, BCA, and ABC. So that was jumping ahead a little bit. It says if the triangle is equilateral, right, 3 congruent sides, then it is equiangular, 3 congruent angles. If it's equiangular, then it is equilateral. And the measure of angle A equals the measure of angle B, which equals the measure of angle C, which is 60 degrees. Okay? Finding unknown measures. It's equiangular, so it's equilateral, so this is easy enough, 6. This is isosceles. Angles opposite are congruent. Isosceles, sides opposite, congruent. Paying attention to this being equilateral, it's equiangular. We just said each angle has to measure 60 degrees. I have congruent angles, and the fact that they're 60 degrees makes this 60, so that means all of these sides are congruent. Just solve for x. Isosceles, sides opposite, okay, and I'll do one more, and then the other 2 are for you. To pick the right 2 sides in this isosceles, all the sides are labeled. Okay, you try 12 and 13. Hint on number 12. What do these 2 measures have to equal? And then 13 is relatively easy. Okay, so hopefully you were able to get those. Finding the values of x and y, a little more complicated. 14, you might want to do like number 11, find out what each one has to be. In 15, those 2 are congruent. And then to find the y, you could take 180 minus 2 times 53, 106. And that's what this one equals. And then on this one, a little bit tricky. We know that these two angles are congruent, the y's. Let's do 10y minus 41 equals 36. And then you could substitute that back in. I'll substitute it up here. 54 minus 39. About 49, that would help. Oops. Sorry about that, I'm going to have to cross off. And if you substitute over here, you'll still get the same thing. So I know this one is 180 minus those two. So 12x plus 22 equals 82. So x equals 5. And the last one, finding the perimeter of the triangle. So it's isosceles. We first find the value of x. Substitute it back in. If it's 9 on one side, it's 9 on the other. And the perimeter is just adding them together. And that's 18 plus 7, which is 25 feet. So, how are the sides and the angles related, of a triangle related, if two or more congruent sides or angles? And it is the sides opposite congruent angles are congruent. Okay, this ends the lesson.